Hey guys, so today we'll be solving the lead code question called shortest common super sequence. Now in this given question, you have been told that there are two strings, that is the string 1 and the string 2. And you need to return the shortest string that has both string 1 and string 2 as subsequence. Now you can clearly see over here is that, let's take for an example, ABAC and CAB. What you can find out that ABAC is part of this, right? You can eventually find ABAC over here, and CAB also you can find with the prefix of this. So eventually it contains both the string as a subsequence and it satisfies the criteria. Further thing which we need to ensure is that it has to be shortest. So we will find out how we can actually go and find the shortest common super sequence. But before jumping into that, there is one core concept which we need to understand over here, and that is the concept of longest common subsequence. In the longest common subsequence, let's deep dive. I will be taking an example of the dynamic programming one, right? So in the dynamic programming LCS, what eventually you do, right? I'll just give a quick recap. Now, eventually, we will construct an 2D vector. Now, this 2D vector or 2D array will be of n plus 1 size and m plus 1, correct? This will be the size of this dynamic programming uh, 2D LCS, right? Now, what we need to do over here is that we need to see that how this gets populated. Now, let's say that we were at any given box, like let's talk about here I comma j. So this I comma j, what we eventually do is that if they were character match at this point, right? If C and C were matching, what we do is that we take I minus 1 box and I minus 1, J minus 1, which is the diagonal box, and we just increment it by 1. Now, same thing is happening over the other place also. You can clearly see over here. If we talk about 2 over here, then it is just the increment of the previous diagonal box, right? So that's how it is working. But what about the other conditions? What I mean by that, let's take an example of this 2. So what we do eventually is that whenever we have a tie, right? Whenever we have a tie, we always select for the maximum. So like let's say that we were at this point, both the characters are not matching. So what we eventually do is that we just take the max of the either the top one or the leftmost one, right? So either the if we can take a we have options over here, right? We can take the above one or the below one. So how we can actually solve this? I mean, let's say that today someone asks you a question. Hey, you have told me that the length of the long LCS is 2. Now, how can you tell me that what are the characters of this LCS? This becomes a tricky part because now what we need to do is that now we need to backtrack it. Now we need to backtrack this 2D DP array. So what eventually is that we will start from the corner. We will start from the bottom rightmost corner. Okay. Now what we need to do is that we have two options over here, right? Now either you can go on the left hand side or either you can go on the the topmost side. It does not matter. So in the given example, we are preferring a top based approach, right? You have the option to actually go to the left also, but for the given, it doesn't matter because at the end you will get the same answer, which I will discuss why. But at the end, it does not matter. What we can eventually do is that we'll use the top base approach. So whenever we see that whenever the top one and the leftmost one have the same values, what we can do is that we will go to the top one and we say that this one is not contributing to our LCS. Just remember this point. When I'm going to the top one, I'm saying the leftmost is not contributing to the LCS. This is a very crucial factor which will come in solving this question. Right. So let's do the traversal. Right now we are focused on solving the question that what are the characters which contributes to the LCS. So we'll move up. We'll arrive at this box, right? And when we arrive at this box, what we need to do is that we need to go further up because we are ignoring the left one again. Now we arrived at this box. Again, we have two options, right? One comma and this box and this box. What we can eventually do is that again we say that at this point there is a character match, right? A and A are matching, so we need to move diagonal. When we move diagonal, we know that we have found a value. But how do we know we have found a diagonal? Because at this point, what would have happened is that when we have iterated up, you would have seen that there is a first character mismatch. B is not matching with A, D is not matching with A suddenly matches with A. So that is the point you decide that, okay, you need to move to the diagonal. Now, once you move to the diagonal, you again you encounter something same, right? I'll just write the answer over here. We have encountered here. Now here also you have another options. Either you can go to the top or you can go to the leftmost. But note, we in the LCS one, we would have already done this part. We are selecting the one which is giving me the maximum answer, right? This one, I comma j minus 1, right? So we are always following this rule. Whenever there is a mismatch between the characters, this character or this character, we are always following this rule that we will select the maximum one. So that means now this the upmost the D, this value is not contributing to my LCS, and the B is not contributing to my LCS, correct? And similarly, once we arrived at C, we know that this is a character match, and hence we found the LCS as CA. So it seems simple enough, right? And one more important thing which might cause a bit of confusion, right? As I had already said that, right? The one which we are following is that the max of this one. But note, at when we had started from this point, right? There was a character mismatch. So if you had done an LCS, you would have gotten something like this max 2,2. But it does not matter. It does not matter which one is actually contributing, either this or this. We are because in the given question we were interested in finding the length. We were not interested in finding the LCS. But if we had preferred a topmost approach, we would have found CA. But if we had preferred a leftmost, like in the sense that we are preferring this, we are not preferring this, something like that, right? So we could have gone down the leftmost path, and we need to ensure that whenever there is a tie, right? Whenever there is a tie between both the values, we are following the leftmost ordering, right? We should not change the ordering all of a sudden. Like, okay, there is a tie between 1 comma 1, now I will go to the top. All of a sudden, do not do that. So always stick with the leftmost approach or the topmost approach. So that is the way to find the LCS, and you will get the LCS answer. So that is one thing which you can eventually do, right? Now in the given question, we are just interested in finding the LCS, and one LCS is sufficient, right? Now let's say that you have found the one LCS. Now what about it? Now note, earlier I had said you that there are characters which are not contributing to this LCS. Now as you can see, the path to the LCS is via this, right? It is something like this. And which are the characters which are not contributing to the LCS? It's these one, right? These are the character which are eventually not okay, not this one, this, and because A and A are contributing, and again we move diagonal, and again B and D, which is these characters are not contributing to our LCS, and again when we arrive here, the final A is not contributing, right? So eventually, when we are traversing back to find the LCS, what we can eventually do is that all the elements which got discarded, we can add it to our result answer. That is for the shortest common super sequence. What this will ensure is that once we are traversing, let's say that B and A are not matching, I am discarding B, right? That means I'm assuming A is contributing to my LCS, right? So that means I will go upward. Once I move upward, I find that D is not contributing. So I will add D. And once there is a character match, I will add A, right? And then I will traverse back to the diagonal. Now in the diagonal, you can see there is another character mismatch. Now I told you that we are following either we can select the max, and if there is a tie between the topmost and the leftmost cell, we'll always go to the maximum one to find the LCS, right? So that means in this scenario, 0 is the lowest one, and that means 0 is not contributing. So we need to write the character which corresponds to this index, right? And similarly, B is not contributing. Now, as you can already know, the C and C is the character match. That means we write C, and we can go back to the remaining character, which is A. So that means in this given scenario, the CA actually is appearing over here. And one thing to note over here is that now once we have traversed back and we have added all the discarded element, you can clearly see that CBDA, CBDA actually appears in this string, and AC ADB also appears. So what has eventually happened is that using the LCS, what I've ensured is that the sequence, which is I have figured out the LCS, right? Now LCS ensures that the characters which are occurring in common in both the one, what we can do is that we can just give some character value, like let's say C1 and C2, the two characters, or like let's say CN. Now, what about the remaining characters? Remaining character is that the concept is that we will add these characters around these LCS characters. Like we can either select the characters from the S1, S2, some characters, not the full complete characters. We can either select some characters from S1, S2, we can select some character again here from S1, S2, and some characters from S2, S1, S2. So doing this, one thing is for sure that while doing this, the ordering of the element remains as it is, as it was there in the original string, right? Because we are traveling from bottom to top, right? So that means we are not skipping any ordering thing which is happening over here. And the next thing is that whenever we are encountering a common character, we are just printing it once, right? It would have occurred twice. Like if you had printed it twice because it was occurring in the string 1 and the string 2, then it would be a problem sum. But LCS is ensuring that the character C1 actually appears one time, and it can be both be utilized by the some previous characters of S1 and S2, so that it can maintain its subsequence. It can maintain its subsequence. So that is the logic behind it, right? So eventually, if you code it out, this is pretty much simple. And let's deep dive into the coding. Now, what I have done is that I've created a 2D DP vector, which you have already done for the LCS. Now, in this 2D DP vector, I think so. If you're not familiar, you can just watch some LCS course, and it's pretty straightforward. I would say. And the next thing is that I'm following a top bottom to top base approach, right? Now in this, I have defined some I comma j variables, and I will keep this while loop running until I reach until these values become it is greater than 0, right? Now what you can eventually do is that if there is a character match, we'll push it in the super sequence string, right? This is the resultant answer, and I will decrement. So this is the equivalent of going to the diagonal, right? This is the equivalent of going to diagonal. And all, and let's say that if there is a, then I have said you that this thing, right? If there is, we need to select the one which is contributing to the max one and print the opposite one, right? So I will just clear the board a bit again. I think so. It's might be a bit of confusion. So again, as you have said over here, like this one would have come from the leftmost one, right? So that means this character D is not contributing to it. So apparently, what I have all coded here is that if moving up maintains the LCS length, then we include this str I minus one in the result, right? Otherwise, we left is better, and so we include the opposite. So it's always like this, right? If we are moving in the leftmost direction, pick the top one, or if you're moving to the up direction, pick the left one. So this code, right? I will not deep dive into it, right? This is exactly doing that. And if you have a conceptual understanding of it, you can pretty much write it yourself, right? And the end, right? At the end, what might happen is that we might have the I and j iteration might have stopped because either one would have become a negative. So what we need to do is that like while doing the traversal, right? This is a corner case, or you might say when the length of the strings are not equal, maybe, right? And in those scenarios, what you need to ensure is that when the I comma j, if one of the value becomes negative, that time we will stop this while loop. So what we need to account is that in either of the cases, if the values we need to append the remaining character to the string, right? So this is code is exactly doing that. And at the end, so since we are pushing it inside the vector, so we are printing it the reverse order actually, right? Because let's say that I printed added b to the vector, the b is added to the vector, the d is added to the vector, now a is added. Now as you might know, we are printing, since we are going from bottom to top, we are going in the reverse order, and that's why we need to the resultant answer which we are eventually storing, we need to reverse that and return. So that's all, guys. This is nothing fancy. And even in the solution, I think so. I do not have not explained you something which is explicitly about this shortest super sequence. And apparently, it's all about LCS. It's all about LCS. So the more you practice the LCS based question, the more you will have a better understanding what is this DPI comma J, I minus 1J, and you can play around with it. And the more you play around with it, the more you understand, okay, what are these values, right? So that's all, guys. The time complexity is n into m, right? Because all we are doing is constructing and traversing this 2D DP, and the space complexity is also n into m. So in the interview, if this comes up, you can pretty much answer this question via this approach. So thank you, guys. I hope you like this video. Do like, share, and subscribe. Thanks.